The Lexicon storage engine is a persistent columnar database designed for immutable linguistic datasets. This manual describes the internal architecture, configuration parameters, and operational procedures. The system employs a multi-tier storage hierarchy consisting of hot tier, warm tier, and cold tier segments. Each tier maintains separate compression and indexing strategies optimized for access patterns at that level. The engine supports append-only writes with asynchronous compaction. Column descriptor records maintain metadata for each indexed column including name, data type, encoding scheme, and compression codec. The descriptor is immutable after column creation. Updates to column properties require creating a new column version and marking the old version as deprecated. Version identifiers follow a sequential numbering scheme incremented on each structural modification. Descriptors are stored in the catalog partition, replicated across all nodes. The encoding layer transforms raw column values into byte representations suitable for compression. Supported encodings include dictionary encoding for low cardinality columns, bit packing for fixed-width integers, and run-length encoding for sequences with repeated values. Encoding selection occurs during segment finalization based on observed cardinality and value distribution. The encoder maintains a lookup table mapping encoded representations back to original values for decoding operations. Compression occurs after encoding using either ZSTD or LZ4 codecs depending on configuration. The compression level parameter accepts values from 1 to 22, with higher values producing smaller output at the cost of increased CPU utilization during writes. Default compression level is 8. Decompression is performed on demand during segment scans. Compressed size is stored in the segment footer for capacity planning purposes. Write buffers accumulate incoming rows until reaching the configured flush threshold, specified in both row count and elapsed time. The threshold rows parameter defaults to 100,000 rows. The threshold seconds parameter defaults to 300 seconds. Whichever threshold is reached first triggers buffer serialization to a new segment file. Multiple buffers may be flushed concurrently if configured parallelism exceeds 1. Segment files are named using a timestamp-based scheme and stored in the segment directory specified by segment path configuration parameter. Each segment contains a fixed header indicating version and row count, followed by compressed column blocks, and concluding with a footer containing offsets and checksums. Segments are immutable once written. The manifest file maintains a registry of all segments with their creation timestamp and status. Compaction processes combine multiple smaller segments into larger consolidated segments to reduce metadata overhead and improve query performance. The compaction process runs asynchronously on a background thread pool. The max segment size parameter controls target size for compacted segments, defaulting to 1 GB. Compaction respects the retention days parameter, which specifies the minimum age for segments eligible for compaction. Index structures are constructed at segment creation time and include bitmap indices for low cardinality columns and B-tree indices for searchable columns. Index construction occurs synchronously before segment transition to writable state. The index type parameter defaults to auto, which selects the appropriate index structure based on observed cardinality. Indices are stored inline within the segment footer and loaded into memory during segment activation. Query execution begins with a scan plan specification defining which segments and columns are required. The planner applies partition pruning based on segment metadata timestamps. For each segment, column blocks are decompressed into memory buffers. Index structures are consulted to identify candidate row positions matching filter predicates. Matching rows are extracted and returned to the caller in the specified order. Memory management employs a least recently used eviction policy when segment cache reaches the configured max cache size parameter, measured in gigabytes. Default cache size is 10 gigabytes. Segments are eligible for eviction after they remain unaccessed for longer than the eviction age seconds parameter, defaulting to 3,600 seconds. Pinned segments are exempted from eviction. Eviction statistics are available through the metrics endpoint. The replication mechanism maintains copies of each segment across multiple nodes specified in the replica count configuration parameter. Write operations are acknowledged only after the segment is persisted to a quorum of replicas. The quorum size is calculated as ceiling of replica count divided by 2. Failed replica nodes automatically trigger re-replication to other available nodes. Replica status is tracked in the cluster state metadata. Consistency guarantees are configurable through the consistency level parameter accepting values of strong, eventual, or weak. Strong consistency requires all replicas acknowledge writes before returning success. Eventual consistency allows immediate return with background replication. Weak consistency returns immediately without replication confirmation. The default setting is strong. Consistency level selection affects latency and durability characteristics. Backup procedures copy all segments and metadata to external storage specified by the backup location parameter. Incremental backups append only newly created segments since the last backup run. Full backups copy all segments regardless of creation date. The backup schedule parameter accepts cron expressions for automated backup execution. Backup status and history are available through the administration API. Recovery operations are initiated when a node restarts. The recovery process scans the segment directory and loads the manifest file to determine which segments exist. Incomplete segments are identified through a recovery metadata marker and discarded. Complete segments are validated using footer checksums. Invalid segments trigger an integrity failure requiring manual intervention. Valid segments are progressively loaded and registered in the segment cache. Monitoring and diagnostics are provided through a metrics endpoint exposing counters for reads, writes, compactions, and cache operations. Latency percentiles are calculated across sliding windows. A health check endpoint validates that all local segments are accessible and responsive. Alerts may be configured for metrics exceeding specified thresholds. All metrics are exposed in Prometheus format. Configuration parameters are specified through configuration files, using YAML syntax. The system searches for configuration files in the config directory specified at startup, defaulting to /etc/lexicon engine/. Configuration changes require a service restart to take effect. Runtime adjustments are not supported. A sampled configuration file with all parameters documented is provided in the distribution.